Welcome to another Everything Digital Health. I'm Marcus Baw. I'm a GP and a digital health specialist, and I've got with me today good friend Simon Chapman, world famous paediatrician. He's somebody I've worked with for a long time, especially in the last 5 years. We've been working on digital growth charts for the Royal College of Paediatrics and Child Health. So we're here to talk about the growth charts that we built. So why don't we start with how we got started with the digital growth charts back in 2020, I think it was.
Totally. Well, I've been a total growth chart junkie ever since. You know, like paediatricians are fascinated in charts. Slightly geeky, slightly statsy, but very practical and very clinical. It's a kind of tool that we use all the time because it's a growth chart. Most people often don't really think of it, but it's actually a really, really sensitive measure of children's growth. So, of children's health. You know, if children are unwell in some non-specific way, even if it's got nothing to do with their hormones and their so on, in fact, the fact you've got badly controlled asthma, you've got inflammatory bowel disease or some other long-term health condition, that's going to cause you not to grow. So in peds, we're sort of it's baked in from the day one that you start on the wards, is you're told about growth charts, and you have to think about, you know, weight and height and head circumference and BMI, because it's something that helps you not only make diagnoses on people that might be ill, it helps you titrate the effect of your treatment on people that you've already got an established diagnosis on to know, you know, is it working? They're going to catch up with their growth. So for been sort of into growth forever. And I'm an endocrinologist effectively now, and that is, you know, spend all my day looking at charts, plotting little dots, and getting really anal about, you know, how you use them and how you render them. So I sort of got involved in charts a good decade ago, but it was only, you know, I've been doing all sorts of apps and things like that around the topic for a long time, but it wasn't really until we got together through the college here. This is the college.
We are in the actual Royal College of Paediatrics today.
So it was here that we kind of started making, you know, applying this to like a real world problem. So it stopped being like a hobby at that stage, and it became something serious. So.
Yeah, it's a bit like that for me. I mean, I'd done some open source playing around with digital growth charts because my mum's a health visitor, and so I knew about growth charts even before I went to medical school. And then I kind of got to thinking, where's the digital version of this? And like, isn't there an app that will tell you what centile they are? And so I'd started playing around with it, written play toy versions, you know, in kind of Ruby, JavaScript, Python, and sort of. It was partly me exploring programming as well. This is 10, 15 years ago. And because I put it out as open source, I think when the Royal College was starting to look at how do we do this in-house as a new project, my name must have come up. So I guess that's one like unsung advantage of open source, is that it's out there as a business card of like the stuff that you can do.
That's the bit I'm still interested to know. How was it that Marcus Baw appeared in the whenever we're talking about this?
I can only assume they Googled it, and there would have just been some blogs by me, and I did some stuff at NHS Hack Day about it. I'd also been involved in an organisation called Lee Hackspace. So I was a co-founder of Lee Hackspace, which is a sort of hackerspace, makerspace type thing up in Lancashire. And we participated in Young Rewired State one year, that was 2015. And the teams that came to Young Rewired State were kind of like teenagers who can code, who are really interested in learning a bit more about coding. And they do a week-long hackathon. And then on day one, you've got to think of a project. And so they were thinking for a while, and then they looked like they were struggling to find anything that was like meaty enough and had some kind of weight and social meaning to it. And I just threw it out, well, there's always growth charts. You know, I can certainly guide you on to how to do this. And I explained what they were and how there's a need for a kind of digital growth chart, sits in a web page, can render and calculate all these things. and they went with it, and they won. They got to the finals of Young Rewired State 2015, and they won the Obesity Data Prize from NHS England that year.
Fantastic.
And we all went to NHS Confed Expo and got this prize. It was amazing, and they got money. They shared, 3 of them shared the £5,000 winnings. So it was like real, it was cool stuff. So I guess all of that will have been in the public domain because I do everything in open source, and somebody will have just Googled it. And I remember Magda, who was our old project manager, emailed me and said, "We're looking to do this. Are you interested?" And I was like, "Yeah, I'm interested. But you need to get this other guy, Simon Chapman, involved." So that's how you got it on.
Yeah, well, I'm very grateful.
So not at all. I mean, I couldn't have done it. I could no way have done it without you. So, you'd already done growth charts implementations at King's College.
Yeah. So there's a guy called Jack Barker who's the CCIO there.
Yeah.
Still, this goes back 10 years now, and I was a new consultant then, and we were going paperless at the time, which I think is anybody watching this that's a clinician that's works in hospitals and stuff will know the pinch point and the pain involved with trying to go paperless. And the paediatricians are the ones that always dig their heels in and saying, "No, we're not doing this until we get our charts."
Yeah.
And the charts are notoriously difficult to implement for all sorts of reasons we'll probably go into, but not least because the various solutions off the shelf are not validated, they're closed source, then there's no sort of transparency over how the maths is done. They just sort of, and actually a lot of them it just goes in the too hard box. If you're an EHR provider and you've got to build a solution for a hospital that encompasses cardiology through gastroenterology, through gynecology, whatever, you've got, peds, which is a relatively small specialty. You're just going to go, "Oh, well, can't I just put an image of a chart and float some dots over it? Is that good enough?" And they probably don't even think hard enough that actually, it's not just an image you're looking at. You actually need some numbers. So, you want a centile and a standard deviation score.
Yeah.
And unpacking all of that into a chart is surprisingly complex. And by the time anyone just does a little bit of investigation into the actual methodology of producing it, you start getting very lost in LMS charts and validation and interpolation, and it gets very mathsy very quickly. People get scared, so they go, "Well, okay, forget it." And so they say, "Let them keep the pain."
Well, that's been the approach of all the GP systems that I've ever used. So naming no names, but there's only a couple of actual GP systems still in use. They have growth charts in them, but when you go and look at what's involved, it is an image. It's like a JPEG of some curvy lines that look close to a growth chart, but they don't look familiar. They don't really look like an RCPCH standard chart. They've been,
and they're all in different colors sometimes as well. If it's not an image, it's like they'll render the lines.
Well, the lines are in like rainbow colors in other systems.
Exactly.
And it just plots a dot wherever you set the age, and then weight or age and then height. And that is close enough to fool the uninitiated that it's a chart. But the problem is it doesn't tell you what the centile is. It doesn't tell you what the standard deviation score is. So you are left as a user of a computer. You're sitting in front of a screen with your eyes looking at the dot and going, "Is it above the 75th? It's below the 91st. So let's call it 79." And you're doing guesswork like that. And you're sat in front of a computer that could have calculated it for you, but hasn't bothered to. And it's really frustrating. I think other really big knock-on effects of not having the calculations is that because there's no number on the centile, it never gets recorded in structured data in the record. So if you want to do a search of all the GP records and come up with the centiles of children and maybe do a research project at national scale, you can't, because there is no structured data in the GP record that would enable you to say, let's look for a SNOMED code that says child growth centile. because it's not ever coded. The only structured data you'd possibly have is the weight. So, but you then have to, if you were doing a national research project like that, you'd have to get the weight, work out how old the child was on that day that the weight was taken, calculate the centile. That's a fast computational task, even if it's not just an impossible logistical one. So I mean, they've all just about abdicated their responsibility to make a system.
So hats off to Jack, because what he did was he came, he already had a go at this. He'd already done the simple implementation of it, and I just happened to find out about it because I was relatively new in the trust, and I'd been doing it in whatever it was, Visual Basic, I think was the first implementation of it I did. And I found out that Jack was doing it. He got some hilarious SQL Server thing, which was the back end to the Allscript system that we had at the time. And we used to sit next to each other in his tiny office, in the basement somewhere, underneath the long lab or whatever. And we just used to write queries and sort of convert it into some charts. So it was really, really exciting and quite a lot of fun. And our first implementation, went live with across the trust, and I think it was in place for about 10, 15 years by the time we finally got ethics to be back in live, which has its own charts. But ours were in place and they were hand built by us, and we had several million measurements, within the first 5 years. It was quite fun to watch it.
And they were proper charts that did all the calculation and all the stuff behind the scenes, and the statistics and stuff.
So from there, it was like a hop, skip, and a jump, really, from doing. Then I thought, I'll do it, in other domains. So I sort of took the calculations and I used them in mobile development and so on. So I did various different sort of trials at it in Dart and JavaScript, and I think I even had a crack at it in Ruby. And in the end of it, it didn't really go anywhere. So then I stopped doing it after a while. So it felt like, okay, this is a hobby, bit of fun journey, but I didn't really expect it to go any further.
And then the Royal College sort of came calling, kind of thing. So I don't know any of the backstory, the internal story of the college, because that was way before I was part of it. But I got this email saying, "Would you like to do these?" And I got you involved. We started having meetings, and we very quickly had working code.
Yeah, within a week.
It was
within a week. We had like a chart on the screen. In Flask, I think it was. Because we originally, I think we had lots of conversations about how we should build it, didn't we? Whether, should it be some sort of application? How should it be embedded in something? Should it,
Well, that's it. I think a lot of the solutions that there are out there, where they exist, things like iGrow, by
I don't know who makes it.
Harlow Printing, that's it, or Harlow Solutions as they're called now. But iGrow is an app that sits outside the electronic health record, and often that means if there's no integration, which I think in most cases there isn't an integration between the EHR and iGrow, you're taking little bits of data out of the record and then you go and put them in the chart, and then it stays in the chart. You can see a chart, but it's not ever integrated into the record. And I think we made a decision early on that wasn't good enough, and what we wanted was full integration into records. So then we start thinking, how are we going to do that? Because all of the electronic record systems across the NHS are slightly different. Some are web-based, some are not web-based and use essentially a native desktop application. There's a whole range of things. So
and it comes also back to the fundamental underlying problem, which is that, like I said at the start, that growth is an underlying measure of children's health. So if the only measurements you ever take are in hospital, well, by default, they're ill at the time that you're measuring them, nearly all the time. And if you've got, therefore, a bunch of measurements to only represent the children's journey when they're ill, you're gonna get sort of a skewed view of what's happening to them. Actually, you just got a bunch of 6 months worth of dots and then you don't see anything for another year or two, and then you get another 6 months of dots. You've got a big gap there in health where nobody's measured them, or they have been measuring them, but probably in another hospital, which means, you know, all of those measurements sequestered in their record, or they're in primary care.
Yeah, well, I mean, wow, that stuff to get into the whole,
Yeah,
you know, we have every patient really that has more than one site of care has got little pockets of data scattered all over the NHS, and that's a massive interoperability problem, which I think it's a huge thing that the NHS has not solved, nowhere near solving at the moment.
But it's solutions like ours that at least are the first step towards that.
It's infrastructure.
If you have a service that you offer, it sort of doesn't really matter, you know, then it's up to the implementers to engage with it, rather than them embedding their own calculator and saying, well, it works for us, everyone else can get lost.
Well, there's so many reasons why it doesn't work to pay each EHR to implement its own. Firstly, we can't afford it. If there's several hundred solutions in use across the NHS and we have to pay each of them to build a bespoke chart system, it's just unaffordable. It's a stupid waste of taxpayer money. So we need to do it once, maybe more than once. You know, it doesn't have to be a single solution, but a small number of solutions should exist, and it should be done correctly. And so we were given an opportunity to do that at the college. So we did it in open source, which meant it was transparent to the entire world, and people could look at the code and actually verify that it was right and tell us whether there were any bugs and that sort of thing. And we're a Royal College, so there wasn't any strong impetus to make it a huge commercial edifice. We're just a non-profit, a charity. We can put this code out there. It was open source from the first commit, and it's still open source, and all the ancillary little bits and pieces we've added have built on that open source kind of treasure chest that we started to build. But I remember how cool it was. Like, to this day, I think we're the only Royal College that has a GitHub repository that's got clinical code in it. I know so there are some other colleges that have got a GitHub repository, but it's got like website things. We've got actual clinical code in.
And more than just one repo, we've got like probably about 20 or 30 repositories now.
Well, that's the kind of next stage of the story, isn't it? Which is that, we built our digital growth charts. They are now doing pretty well. We've got all of Wales using digital growth charts that we built. We've got numerous trusts across England, lots of trusts in Scotland, and we've got one of the GP systems is using our growth charts for specialist care, so Downs and Turner syndrome. So it's starting to
get international. We've got in America they're using it now,
and
with different references in Australia.
So it's by building that open source engine that does the calculations right, and we created that little React component so that it can be embedded into the software. And that model's working really well, actually. We've had good feedback about the integratability of it all. We've had good feedback about documentation. From day one, we're very upfront about the regulation that we would need to go through. It's a medical device, and we just did the medical device regulation and published our medical device
safety case.
So the clinical safety case and the medical device regulation stuff is all just public on the documentation side. So it's not something we hide or that you've got to ask us for. And these things, which are, we're sat here in the Royal College of Paediatrics and Child Health because we happen to be here for a bit of a sort of team hack week kind of thing. But I thought it'd be really good to record the Digital Growth Charts episode here because they have the awards that we won. So in 2020, we got Best Health Tech Solution of the Year from HTN. And then in partnership with the
Welsh
Digital Health and Care Wales, the Welsh Clinical Portal applied and won again the best solution for clinicians in 2024. So, I mean, awards, awards. I think we both have opinions about some of the health tech awards that are out there, but obviously these ones are very good. Like the HTN awards are the best ones to have. But it is nice to get some kind of recognition, and it's important that, like, part of it really for us is just getting word out about what we've been doing. So to me, the awards are less important than the actual publicity and, saying this is a good news story about open source as well. We've managed to do something that I've been told many times is impossible. The NHS can't deal with open source, I've been told, but many times been told. And I've built something in open source under the auspices of the college and with you, and it's now working. And we're building other things in open source. And, so we've managed to create like a little open source incubator. So I guess that brings us on to like the next stage of the story, really, which is how we ended up developing this little software development house within the college. So, maybe you want to take that bit of the story.
So the next thing that happened, I think, a Royal College is possibly one of the most conservative kind of old-fashioned organisations that can possibly exist. That's not, it's quite rude, but there's slow-moving things, and in a way, rightly so, because they represent, standards, and they represent governance and clinical, whatever, best practice. So in a way, they kind of have to move slowly.
Yeah.
But at the same time, then asking a Royal College to adopt something like, instead of just saying, could you design an app, which for most colleges, I think, would involve commissioning it and then somehow arguing over hosting,
procuring it from the marketplace.
Yeah. The idea that you would say, okay, no, as a college, we want you literally to build it in-house and maintain it in-house and take responsibility for all of the, it's like an artifact. It's a non-intellectual property. So, to take responsibility for that when it's something you've never done before, I kind of find it quite impressive that the college had the foresight to do that. And I think they possibly didn't really know what they were getting into when they first started with the charts, but it didn't take long for them to see the benefits, partly because we started to get customers, but mostly I think because it as the word spread, it started to become obvious that this was another way to do something important. And what does a Royal College do apart from training the future generations of paediatricians and so on? It actually sets clinical standards, and therefore it sits at a national level. And it's exactly, for me, the role of the college is to influence the way healthcare is delivered. And you can't rely on a hospital by, commissioning and procuring some software package. Well, that will work for their hospital, but you need something that sits above that sets the standards about what we buy and what we use and how we use it. And so the college, I think, kind of got the whiff of the idea that through software we could effectively be influencing standards, which is a kind of bizarre concept for them to get, to be honest. And I think once they started to get that idea, I think there were a couple of things, because it was really just you and me originally, surrounded by people in the college that were supportive but not totally understanding or not possibly seeing the potential. But very shortly after, we got a senior head of digital, Richard Burley, who joined, and that was sort of transformative. He came to us from the vets, so
RCPCH.
Animals, kids, right? Similar. And he was brilliant because he sort of got it straight from the get-go, and was therefore able to kind of argue the case at a very senior level in the organisation. Say, no, listen, this could be really big for the college. This could be, a new way of engaging with our users, engaging with our, and this is another thing about the Royal College of Paediatrics people often don't know, is that it's not just a sort of a pressure group for the profession, though. I mean, it is that. It's not like the ophthalmologist or something where you just, you're just there for the ophthalmologists. I think we're possibly the only real college who is explicitly for the kids and the families as well. So RCPCH does a lot of policy work, a lot
kind
of
of advocacy group for that kind of thing, for child healthcare
exactly.
globally. Yeah.
The standards of care in children, but also actually globally for child health. They have their fingers in a lot of pies, which is about influencing national policy and international policy on children and child health, which has an impact on, even the bigger social political things. The college will have a stance on, which I really love, that whole,
it's very cool to see
activism that, you maybe wouldn't see in another college. So the idea that the college might have the vision to think, well, actually, digital is going to have an impact here. By maintaining and producing digital artifacts, you can actually influence policy because you're gathering data for a start, which you need to make a change, but also you're actually building building apps and things which have reach, and they have reach. Because everyone's got a mobile phone now, and everybody's got a desktop computer, and we all have to log in to our workstations at work wherever we are. So
it starts to transform the college's ability to influence the rest of the world if you can do that in a digital way.
Yeah.
Because I've written a blog post about this, which is called Royal Colleges 3.0.
Yeah.
Best practice as code.
Totally.
And it's like Royal Colleges 1.0 is the existence of a club that's for that special interest in medicine, and it has some guidance and their documents on paper, and you write to the college and they send you them in the post. That did happen back in the 90s, and then the internet comes along, and now Royal Colleges slowly but surely took some of them into the 2000s to go, we should probably have a website, shouldn't we? But Royal Colleges 2.0 is it's a slightly more rapid cycle of development and guidance and circulation and dissemination of this guidance through the web. You've got PDFs and they're all on the website and stuff. For better or for worse, it's easy to get them, but sometimes difficult to search them, and they're not always as readily available as you want. And the problem, of course, is that the guidance is coming faster and faster now, and we're getting to the stage where even a very engaged clinician is going to struggle to keep up with all the potentially relevant guidance that could come across their area of practice at the speed it's coming. And that's why you need Royal Colleges 3.0, which is best practice as code. So that best practice, instead of being a PDF that you have to absorb mentally and sort of take a snapshot of at the time you read it and go, I'll remember that next time I see a patient with this disease, you need it to be coming at you just in time. So through the electronic health record, that needs to become a tool that's like the sat-nav of medicine. It doesn't drive for you. You're still driving, but it gives you guidance about where you should be going. So as you seeing a patient and developing the kind of clinical story and getting the facts straight and agreeing what the management might be with the patient, you can be prompted with guidance that's coming direct from trusted bodies like Royal Colleges and other standard setting bodies, but digitally. And that's the dream. That's it's a mind-blowing next step, but that is where we've got to be headed,
Totally. Well, I was really struck during the pandemic where there was this new condition came out of the woodwork virtually overnight. This thing that came to be known as PIMS-TS, which was this, it was a little bit like Kawasaki's disease. It was a catastrophic event for a young person. It was relatively rare, but it was fatal. And it was this multi-inflammatory system type thing.
Yeah.
That kids, would get COVID, and a few days later they would present clapped out, hypotensive, and they would have to go off to ICU, and they were at death's door, and some died. I mean, it was awful. Yeah. And it was it was awful equally for clinicians on the receiving end of this, who treating it like sepsis didn't really work. What do we do? What evidence is there? And I just remember in the first few weeks of this sort of coming out of the woodwork, it was all online now because everyone suddenly had discovered virtual working.
Yeah.
And there was this webinar that an academic had pulled together a case series nationally, and had managed to reach out to some colleagues in America who'd sort of done the same. And they were comparing and contrasting the differences between Pim's TS and Kawasaki's disease. And I swear there must have been like 1,000 people on the call watching. And it was like the first experience I had in my career where everyone was quite so engaged, and people, because it was like at 10 o'clock at night or something like that. And it was obviously,
it's a very strange time, wasn't it? The pandemic, because there's lots of those kind of things going on, and it felt like it was an international global emergency. And suddenly,
and we were all energized
to get this sorted, and but then it got pulled out, and
the point was that it suddenly made me realize that, like, if you're going to be, I don't know, in A&E and you see somebody who's got COVID and you want to develop a risk score that might involve, I don't know, the normal things you have, like respiratory rate and CRP or whatever, you pull together a bunch of biomarkers, clinical markers, and you roll them into a score, and you can correlate that with outcome, and it's only medics that are seeing it a lot and measuring it on the fly, wanting to publish it to make sure that people, you can turn around scores like this relatively quickly. And yet, if you then come up with a score that's going to be relatively, simple calculated, but still needs implementing, if you then take that off to say, whoever else, say, could you put this in my EHR now, because I need it now, they'll go, well, we'll get round to it. You can have it in 6 months, have it in a year. Well, that's just not really good enough. And so what you need is the medics be able to organize themselves, build these things, so that then they make them and disseminate them quickly. So if you were to come up with a COVID calculator and you plug it into as an API or something like that, then suddenly everyone has access to it. And it suddenly made me realize in a very short space of time the power of medics kind of taking control of software, because it allows us to do our job more reactively and and faster and more accurately,
quality and at lower cost potentially as well.
And it feels like we're control freaks in medicine generally. We don't, I don't like the fact that we got outsourced so much of this power to these big companies that
well, it feels like there's a risk of losing control of medicine as more and more of medicine becomes software driven. If we don't control the software, we don't control the profession. And we are absolutely starved for some of the tools that we need. So I call them, the umbrella term I like is to use clinical digital tools, because that sort of covers most things. They're clinical, they work in a computer, and they just enable you to do stuff better. But we don't get them, do we? There are some websites like MDCalc, which are proof positive of the need for these things, but they're not embedded in our systems. Generally, there might be a handful of clinical calculators in any given clinical system, but it's not the whole gamut of things we need. They tend to be very expensive. If we commission a clinical calculator to be added to a system, like you say, you get it in 9 to 18 months' time, depending on how long the procurement took and how much money was involved, and you've got to do that with every single system. And just mathematically, the NHS cannot afford that. So we have to do a different model, which is like what essentially we've set up. APIs that do the calculation. And you can have thousands of those APIs if you need to. They could all be run by small number of organizations. There could be dozens of organizations involved, but at least that makes it easier for every single one of those EPR vendors to then connect to the API and say, right, well, we can connect to this one API provider, say the Royal College of Physicians, and
so who better to do this for, right? Because it's the medics that are going to be the best place to be able to design a tool, develop a tool. And the way we do it here in the college is we have a sort of set what we call the boards. So we've got the development board, which is the software guys, really just you and me and Michael. And then we've got the project board. The project board is this magical thing which is full of the great and the good from across, crowdsourced from across the college. So all the membership, so the professors and the clinicians and the statisticians and the allied health professionals, the midwives and the health visitors. And we can draw on all that expertise to come up with a sort of a wish list of saying, okay, these are the things we're going to build. We're going to build these standards, and we're going to sign it off and badge it ourselves so that we can be certain that it reaches the rigor and so on.
Yeah.
And we're going to review. We've got a review process, which is all kind of baked into the way the college does stuff, because that's how the college works.
And a lot of these clinical calculators are quite simple, so they're often just adding up a few scores.
Yeah.
And although the implementation detail of doing that automatically is difficult, but at their face value, the APIs are not that tricky. I think growth charts is actually one of the more difficult ones because it's got these complex statistical calculations in the back end. But we can get a lot of clinical calculators done for very little clinical time. And then there are now so many clinicians who can code that it's actually very likely that we'd be able to get them written.
Yeah.
If they do, like our model, open source and peer review of them, then we're very likely to get high quality, absolutely guaranteed accurate calculators. And although you can never really be sure that they're bug free, you can employ testing and you can use the with enough eyes, all bugs are shallow kind of approach. That means that if you put it out there and it's open source and there's enough clinicians reviewing this thing, it will be found out if there is a bug. So you can certainly say that it's likely to be less buggy than a closed source proprietary piece of code that you are not allowed to look at, which could be correct, but it could not be correct. And how would we know the difference? We wouldn't find out until harm has occurred and somebody says, actually, in retrospect, it turns out this calculator's wrong. And that's happened twice, at least that I know of, in the past 5 years in GP systems, where the implementation of things like QRisk clinical calculators has either over or underestimated the risk of a disease and resulted in overtreatment or undertreatment. And that really happened, and we're seemingly fine with it. Nobody lost the job and never got sued.
We've just taken delivery of Epic at Chapman, where I work. I was asked to look at the growth charts, and my first question was, well, can you show me the code? I want to see your methodology. And it took, I think, 2 years to implement. They never did. Stonewalled, all my emails ignored. And now we have growth charts. I still, to this day, have no idea. I said, could you show me maybe your unit tests? They laughed at me. They said, well, in a number like a 3-year-old or 4-year-old. It's like, where's the governance around this issue? Like, there is none. At least up for maybe they do have this stuff, but they weren't willing to share it with me. So I just kind of, it really put me off big tech in a massive way, because I really felt like nobody gave a shit about me and my requirements. And for me, getting 3 decimal places worth of accuracy is really actually important. I know it may not make a massive difference to the young person whether or not they're on the 2.3 cent or 2.4.
But it's important. If you can make it that accurate, then you should make it that accurate.
Well, but we're publishing, like, we're a research centre. So you're giving, drugs to kids that are going to affect their growth, and you want to be measuring the output, and you're going to be publishing that, and then ultimately releasing these agents onto the market saying they're safe or not safe. And if the underlying calculator that you're using is flawed, then presumably that has a knock-on effect for the actual, the data that people are collecting. I just think it's totally crucial to be able to rely on there's so much grey area in medicine. The bits that are black and white and that are objective, we should really bloody well use it. We need to be able to define that it's helpful and be able to say how. We spent a long time on the testing element of the calculations. It took us a good 6 months.
And we had Tim Cole involved. He's the person who essentially created the idea of the LMS method for creating a growth chart and data set kind of thing. so yeah, I mean, we that's something that I think as a model, I'd very much like to see other colleges take on. And I think, as we've talked about, we as a college here would be very keen to sort of disseminate that message and share how we've done it. A lot of our working's in the open anyway, but we've built a little tech unit here. And how do we do that? Well, you know, some of it's persuasion and it's talking to people. And so the politics, the culture, the medicine, the tech, like, I'd like to share as much of that as possible. And part of talking, you know, part of this YouTube channel was about that, was about, like, let's see where we can find good practice and disseminate that really well. So that we are looking at a future where other colleges are picking this up, and there'll be a unit like this in every single college.
That'd be the idea, because, like, you know, the boundaries of our expertise reach, you know, as far as adolescence and maybe early adulthood, and, you know, down the other end to prematurity and so on. So that's great for us. But, you know, what about anesthetics or pediatric anesthetics? We can maybe just about cover. But, you know, what about all of those other specialties? It would make perfect sense to have, because if there's that level of interest, which there appears to be across the membership of the College of Pediatrics, then it's going to be the same everywhere else.
Oh, absolutely. I think the profession will really go for it, especially when they realise they can participate. That when they participate, that their contributions are essentially being put to the public good. Whereas there's been too many stories in past decades of clinicians being sort of seconded almost to help improve the clinical tools that were built into existing electronic records. And essentially you're seconding NHS staff to go and make a commercial product better for the owners of the commercial product. And then when you've done that process, they will look at you and say, well, thank you for helping us make it better. The bill for this product that you helped us make is going to double because it's now got a feature in it that's so good. I mean, there's a horrific story of this thing called Map of Medicine, which sort of died a death in the early 2010s, but it was almost like a crowdsourced Wikipedia of all of medicine and the structure of our decision making, and almost like a tree and branch. How do we decide on medicine? And it was all crowdsourced from clinicians. And then the company essentially said, great, thanks. That will be, and they were charging individual PCTs, I think at the time it was, for access to it again. So we'd all put the stuff in there, and then it was like, no, thank you, you can pay us. And a lot of PCTs couldn't afford it. And so they actually went.
Sounds a bit like Twitter.
It just imploded. And it's a real shame that happened. I apologize if I've got the exact stories of how Map of Medicine worked, but that was my take on it as I was a junior. I was a GP registrar at the time, and we thought it was going to be amazing, and then we realized we couldn't actually have it. And we don't want to get bitten like that again. So that's why, absolutely, since day one, I've just been like, open source, open source, open source, and I will not accept anything else, because that is the defense against that bait and switch where they take your intellectual property and then say, and now we're going to charge you for it. You know, we as clinicians can build these things, and we can make it safe, and we can make it secure, and, you know, we're proving it every day here. I think that's probably a good place to stop. I think, thank you very much, Simon, for coming on the show. And, you know, I'm just gradually getting started with this thing. I think it's like your 6 or 7 episodes in. And I'd love to have you back. We've got lots more we can talk about, because we're down here in the college actually to work on 2 or 3 completely different projects that we haven't mentioned today. But we definitely need to have you back on to talk about those.
Oh, I'll be delighted. Thanks very much for having me.
Thanks, Simon.
Yeah.
Bye, everyone.
Bye.